complex number and what is a complex conjugate. Okay, so there's lots of videos out there on what an imaginary number is. And essentially an imaginary number, which it has an unfortunate name because it's not imaginary, the number does exist. So we define an imaginary number as I, and it is defined as the square root of -1. So let's say you had the square root of -25, for instance. That has an imaginary part, and so it's going to be 5i. Square root of 25, 5 and 5, it's 5. And the negative here, excuse me, meant to make an error. I don't know what I made there. But the negative there is the I part. So you always pull that out first. Anyway, that just gives you look up imaginary numbers if you need more than that. There's lots of good explanations out there. I have maybe one that's okay, who knows. But anyway, so what we want to do then is define a complex number. So a complex number is a number with a real part and an imaginary part. They're always of this form, a plus bi, where a and b are real numbers, like what you're used to, like the number pi, or 3.1, 3.2, or 2, or 7, integers, natural numbers, whole numbers, the system you've used since you're in the kindergarten when you learned about natural numbers. So anyway, a complex number now combines the real numbers with an imaginary. And so a and b are just any number that you're used to using. And then I is the complex part. And so if you had, for instance, I don't know, 7 plus the square root of -45. Okay? This is going to be a complex number because of that negative under the square root. So, 45 breaks into, I don't know, how good you are at solving, breaking down radicals, but here you go. 45 breaks into 9 and 5, which also breaks into 3 and 3. And so if you think about it, the square root of 9 is 3. Well, when you find a pair, that'll come outside the square root. So 7 plus 3, the imaginary part, I, and then the square root of 5 is left over. So typically that's how that's written. Now, once you have a complex number, you can do anything with it. So let's say you had 7 plus 2i as one complex number, and we're going to add that to another number of 6 minus 5i. Well, you just treat I like a variable and add. So 7 and 6 is 13. 2 and -5 is -3i. Okay? So you can add complex numbers. You can multiply complex numbers. So let's say you had 7 plus 2i times 3 minus, let's just go 3 minus I. So we're going to multiply these two complex numbers. Well, in this case, you distribute. 7 times 3 is 21. 7 times I is -7i. 2i times 3 is plus 6i. 2i times -i is -2i squared. My brain is locking up. So then you go ahead and -2i squared becomes a positive 2. Because I didn't define, I probably should have defined that, but I'm hoping you kind of know this already. I squared is -1. Because I is equal to the square root of -1, if you were to go ahead and square both sides, sorry, I kind of jumped the gun on that one. If you square both sides, you end up with I squared equaling -1 because a square eliminates the radical. So here those would cancel out. And so what we have here, let me slow it down a little bit. Let me back up, backtrack. So what we would do here is I squared is a -1. And -1 times -1 is a positive 1. So that's where I ended up with the 2 there. And then 7i and 6i you can combine to negative 1i, and then 21 we'll just bring down. Now, we always want to write them as a complex number. So we put all of our numbers out front, our imaginary stuff in the back. Well, 21 and 2 becomes 23 minus I. And there's the complex answer of when you multiply those two complex numbers. Okay, so you can also divide them, but that's almost a video in itself, and it will take a lot more time to explain. But you could divide them. If you had 1 plus I divided by 2 minus I, we could divide these. Well, I guess that makes sense. So this would be a good spot. We can do this problem. So here we got two complex numbers, and we're going to divide them. In order to divide them, you need what's called a complex conjugate. This is not the only place you use complex conjugates, but it's a good place to start, and usually where people start. So a complex conjugate is this. If I have a complex number, say a plus bi, anything, its complex conjugate is a minus bi. What's kind of cool is if you multiply complex conjugates, a plus bi and a minus bi, what happens is the imaginary part is going to disappear. It is now going to be a real number when we're done, which is a kind of a beautiful thing. So if you multiplied this, you'd have a squared plus, a squared minus ab, I'll put a plus and negative, same thing, abi, and then plus abi, and then minus b squared I squared. Well, minus abi and plus abi, that's 0. So that's gone. And so then you've got a squared. Then I squared is negative 1. So that becomes a plus b squared. So a squared plus b squared is your final answer. The conjugate, the imaginary part of the conjugate's gone. And so we've got this nice, doesn't look nice, but this nice real number to deal with instead of imaginary. So how does that work in terms of this problem that I said we would divide these? Well, you typically don't want radicals or imaginary numbers in the denominator or in the divisor. This is a throwback to before computers and before calculators. It was really hard to take a number and then divide it by its imaginary part. But now you can plug this into Google and it'll spit the answer out in 2 seconds, or less than that, however it takes you longer to type it in. But I think there's still some value in knowing this stuff. And so you've got 2 minus I, and you would multiply that by 2 plus I on top and bottom. So that's whatever the denominator is. So we multiply by its conjugate. It says 2 minus I, its conjugate is 2 plus I. And what you end up with is 2 minus I over 2 plus I divided by 2 plus I is essentially 1. So I've multiplied this by a really fancy number 1. And then you multiply the top and the bottom, and what you end up with, so I'll go ahead and do that. 1 times 2 is 2 plus I plus 2I plus I squared over 4 plus 2I minus 2I minus I squared. And you simplify that bottom, these cross out. Negative I squared is positive 1, and so you have 5 on the bottom. On the top, this is negative 1 again, I squared. 2 minus 1 is 1, and I plus 2I is 3I. And so now you've got 1/5 plus 3I over 5. And we've used the conjugate. We're going to use conjugates in polynomials, and complex conjugates seem to pop up anytime you're dealing with polynomials, because roots of polynomials always come in pairs when you're talking about imaginary numbers or the complex conjugates. So that's where we're headed with this, but it's good to essentially know what is a complex number? What is its conjugate? You're kind of learning the vocabulary of the math that you're going to need later on if you're going into some advanced math areas. So best of luck. Hope this helps, and see you next time.